video is going to help you learn how to solve radical equations. Equations that have square roots, cube roots, any other kind of root in it. So, first example, notice we have a square root in here. Your first step is always going to be to isolate the radical. Whatever you see is this piece, we want to get it alone on one side of the equal sign first. So I notice I need to get rid of this 2 first. Since it's a positive 2, I'm going to subtract 2 first to the other side. Now I have my radical isolated. I cannot combine these are not like terms, so I just bring it down. First step is done, isolate the radical. Second step is we want to do whatever we have to do to get x by itself, to solve for x. So to get rid of this radical, I am going to square it because the opposite of a square root is to square. What I do to one side, I have to do to the other side of the equal sign. So when I square this square root, I am just left with x plus 10. Now I need to square this out. Remember, this is a huge mistake students tend to make. Remember, this squared actually means that there are 2 of these parentheses. There's 2 x minus 2's there. So when you multiply this out, you're going to do x times x, which is x squared. You're going to do negative 2 times x to get negative 2x, x times negative 2 to get negative 2x, and negative 2 times negative 2 to get positive 4. So carefully use your FOIL or your box or whatever you do to multiply this binomial out to get this. Now when I look at what I'm left with, I notice that I have an x squared term. Anytime you have an x squared term, that usually means I'm going to need to factor at one point, which means I have to have it equal to 0 in order to be able to factor to solve a quadratic. So I want to get these 2 terms over here. So I'm going to minus the x, and I'm going to minus the 10. All right, so now it's going to be equal to 0 once I finish combining all of my like terms. X squared has nothing to combine with, so I'm going to bring it down. I got a lot of x's here to combine. Negative 2x, and negative x combines to be a negative 5x. And 4 minus 10 is negative 6. Now this looks like something that I can factor. I'm looking for 2 numbers to multiply to negative 6 and add to negative 5. Therefore, my factors are negative 6 and positive 1. So my solutions, when I set both of these equal to 0, are 6 and negative 1. So now we have found the solutions for x. If you forgot how to do the factoring, refer back to one of my other videos about how to factor using the Xbox method or by using the grouping method. That will help you get from here to find those solutions. All right, we have one final step. This will be our third step, is we need to check our solutions to make sure they work. A lot of times when we have radicals, we tend to have extraneous solutions. So don't skip the check part because it will mess you up. You will get wrong answers. So in order to check, all you do is you plug in your solutions back in for x. So for the first check, 2 plus the square root. Now I'm going to plug in my first solution of 6 plus 10 equals, and I'm going to plug in the same solution again of 6. If this is the correct solution, that equation will equal out and be true. So 6 plus 10 is 16. The square root of 16 is 4. 2 plus 4, does that equal 6? Yes, that is true. So 6 is definitely one of our solutions. Now let's check the 1. So if I plug in negative 1 to the same equation, 2 plus the square root, I'm going to plug in my negative 1 solution, plus 10 equals, plug in negative 1 again for x. Let's check and see if it works. Negative 1 plus 10 is 9. Square root of 9 is 3. 2 plus 3, does that equal negative 1? Well, that does not work because this is 5 It does not equal -1. Therefore, -1 is an extraneous solution. It is not a solution for this equation. So 6 is our only solution. Now you can see why it's really important that you check, because that does occasionally happen. All right, example 2. Notice this time we have a cube root. In the last example, we undid a square root by squaring it. So the opposite of a cube root would be to cube it. Before you do that, make sure that your cube root is isolated. If we had anything multiplied or added on either side here, we would need to get rid of that first. But my cube root is already isolated on one side of the equal sign. So we can go ahead and get rid of the cube root by cubing both sides of the equal sign. So this cube will cancel this cube root, and I'm left with 10 minus 3x equals -2 cubed, which means -2 times -2, which is 4. 4 times -2 is -8. So that's what that means. So this equals -8. Now, step 2, we just solve for x. So I'm solving just a very basic algebra problem that you've been doing for a while now. I'm going to get rid of the 10 by subtracting it. I'm left with -3x equals -18. To get rid of the -3, I'm going to divide by -3 on both sides. X is 6. Now let's do our very important check step to make sure that this solution is not extraneous. I'm going to plug 6 back into my original equation for x. So I'm checking to see if the cube root of 10 minus 3 times 6 really equals -2. Well, let's see if it works out. 18, 10 minus 18 is -8. The cube root of -8 is in fact -2. So it checks out. 6 is a solution to this equation. All right, this example is a little bit different. Notice we don't have a radical, we have a fractional exponent. So I'm going to show you how that's a little bit different. Again, we want to isolate this piece. Just like we were reducing the radical, we want to isolate this fractional exponent first. So I want to get rid of that 3. Right now this is 3 times this, so to undo that multiplication, I'm going to divide both sides by 3. So x to the 5/4, 3 goes into this 32 times. Now, here's what I want you to think about. I want to get rid of this 5/4 because I'm trying to solve for x. What I really want it to be is x to the first power, because that means just x, right? So in order to get rid of this 5/4, if I multiplied it to the power of 4/5, remember that power to a power, you multiply them together. What is 5 times 4 divided by 4 times 5? 20 over 20, that's 1. So that's how we can cancel out this exponent. Now, of course, what we do to one side of the equation, we have to do to the other side of the equation. So since I'm raising this side to the power of 4/5, I'm going to raise this side to the power of 4/5. And that's how I'm going to get my x by itself. Now, you're welcome to type this into your calculator, but if we think about how we do this in our head, we're taking the 5th root, remember the root is the denominator, the 5th root of 32 is 2, and then 2 to the 4th power is 16. 2 times 2 is 4. 4 times 4 is 16. So x is 16. And you, of course, could plug it in for x and check your answer as well. All right, this will be our final example. Notice again we have a fractional exponent. We want to get this piece isolated first on one side of the equal sign so that we can solve it. So I want to get rid of this 3. This 3 is being multiplied. To undo that multiplication, I'm going to divide both sides by 3 as my first step. And I'm left with 4x minus 3 raised to the 2/3 power. 75 divided by 3 leaves me with 25. Now I want to get rid of this fractional exponent. Remember, to cancel it out, we just raise it to the power of the reciprocal. So I'm going to raise this to the power of 3/2, because this is 6 over 6, which is just 1, which will cancel out this exponent. If I multiply this side of the equation to the 3/2 power, I have to multiply this side, raise this side of the equation to the same power. So I've raised both sides to the power of 3/2. All right, so that canceled this out, and we're left with 4x minus 3. Remember, the denominator is the root. So I'm going to take the square root of 25, which is 5. 5 raised to the 3rd power is 125. All right, now we just have to solve for x. So I'm going to add 3 first. So I'm left with 4x equals 128. Last to solve for x is I'm going to divide both sides by 4. X is 32. And that's it for solving radical equations.